Hello friends, we are going to solve this problem. In this problem they given F is one vector field they given. We want to prove that the F is irrotational and incompressible fluid flow. Then find its complex potential. So first we start with how the function is irrotational. Irrotational means its curl is 0 or curl is free. So curl of F vector is 0. This implies F vector field F is, so this is a F vector is irrotational. So now I want to find curl of F vector. So F is the given I component, J and K component, then dou by dou x operator, dou by dou y, dou by dou z. So there is a only two-dimensional flow. So z component is 0. This guy is y divided by x square plus y square, x divided by x square plus y square. Now you taken as this is P, this is Q, you can we assume that. Now we want to find this one is I times, these all are independent of, so this guy is become 0 only will come, 0 minus 0 minus j cat also 0 minus 0 only will come, but plus k hat times dou p by dou y minus dou q by dou x, you will get it. Correct. So first I want to calculate what is the dou phi by dou y. Dou phi by dou y equal to, so x square plus y square the whole square. So u is independent of y, so it's automatically 0 minus x times, I want to take derivative of the denominator, that is 2y. So dou phi by dou y equal to minus 2 times xy divided x square plus y square the whole square. This is varied, x comma y is not equal to 0. Similarly, I want to calculate dou q by dou x. The same way only, the numerator is independent of x. So the denominator is x square plus y square whole square. The numerator is independent of x. So the first term is 0 minus y times 2x. So you will get it as minus 2 times xy x square plus y square the whole square. Here x comma y is not equal to 0 comma 0. Now this implies gradient curl of f equal to k component times 2xy, dou phi by dou y is minus time 2xy divided by x square plus y square the whole square minus, again one minus with this, so it's become plus 2xy divided by x square plus y square the whole square. So this is 0. So this implies F vector is irrotational. Second, I want to prove that F is incompressible. What is incompressible means? Suppose the vector F vector is incompressible, the fluid flow is incremental. This means that the density of the fluid flow is constant. So whenever the fluid is constant, the density is constant, their mass also, this implies mass is constant. So this implies F is conservative. So vector F vector is conservative means divergence of F vector is 0. So that is the time. So I want to prove that F is incompressible means their density is constant. Whenever density is constant means mass is constant. Mass is constant means the fluid flow is F is conservative. Conservative means divergence of F vector is 0. This implies what is the divergence of F? So it's a two-dimensional. So dou F by dou X plus dou F by dou Y equal to 0. So F vector is already the given. So F is A is there. So everywhere the A will be there. I forget to miss you. So here A will be there. Here also A will be there. Here also A. Here also E. Here also E. Here also E. Now F vector is A times X divided by X square plus Y square I cat plus Y divided by X square plus Y square times J cat. Now I want to divergence means I want to, this is I already taken phi, this is already taken as a q. So divergence of F vector is dou p by dou x plus dou q by dou y. I want to calculate. So dou phi by dou x, what will come? So denominator x square plus y square the whole square. You want to take derivative with respect to x only. So you will get as x square plus y square minus, you kept as it is and take the denominator of 2x is 2 times x. This is plus, similarly here x square plus y square the whole square. Here also x square plus y square will be there. You take the derivative of y, 2 times y will come. So the first one is x square. So y square minus x square divided by x square plus y square the whole square plus x square minus y square divided by x square plus y square the whole square. So if you add together this x and this x cancel, y square is cancelled. So divergence of F vector is 0. So this implies I want to prove that the fluid flow is incompressible fluid flow. I want to free or divergence free. Divergence. So clearly you assume that x comma y is not equal to 0. Then only these all are valid. Fine. Now I want to find the, so this is the first part I will complete it. So first I want to show that F is irrotational and incompressible. So both I have done. Now I want to prove that the function, find the complex potential. What is the complex potential? I know that function f is conservative. So I can say that f vector equal to some gradient of phi I can write. Okay. So this implies divergence of f equal to 0 implies dou square phi by dou x square plus dou square phi by dou y square equal to 0. So this implies this is complex potential. So potential function. So phi is harmonic. So this is true. So every analytic function lead to a, so the phi is harmonic. So I know that suppose function f of z is analytic, the real part are harmonic, I know that. Correct? So I can accept that one fluid. So hereafter I note that one fluid flow. So that is I will take as a omega of Ez equal to phi of x comma y plus I time psi of x comma y. So this is why this is true means this is you can consider as the result or definition. Every analytic function leads to an irrotational and incompressible flow. Okay. So that phi is getting from the f. So I want to determine what is the omega of Ez. So how I want to say omega phi equal to, so that is gradient of phi equal to, I got it as a times x divided by x square plus y square I cat plus a times y divided by x square plus y square j cat. So this implies dou phi by dou x equal to a times x divided by x square plus y square dou phi by dou y equal to a times y divided by x square plus y square. So this implies phi equal to a divided by 2 natural logarithm of x square plus y square plus some function of you take function of y. So from this result, okay, now I will take dou phi by dou y. So a times y divided by x square plus y square plus g prime of y. So I will compare these two. G prime of y equal to some 0. So g of y equal to some constant. So this implies phi of x comma y equal to a divided by 2 natural logarithm of x square plus y square plus some constant. Now I want to find omega of Ez. How I can find the omega of Ez? Omega of Ez is equal to, if we use the Milne-Thomson rule, phi of x at x equal to, so you will get it as A divided by Ez plus, that is 0 will come, correct? I times 0 times dz will get. So if you are integrating, you will get it as natural logarithm of Ez. This is our potential of some constant, integration constant. So this is our complex potential. So you no need to calculate dou phi and phi also, directly you can apply this result from the Milne-Thomson method. I hope you understand how do you prove that the given vector field is conservative and irrotational. Then using that, how to find the complex potential. Thank you for watching this video.